Hello, I am Dr. Rakesh Sanchiti from Department of Chemistry, Arts, Commerce and Science College, Chandwad, District Nasik. I am thankful to the FDP organizers of KTHM College, Nasik, as well as to the HRDC SPPU Pune. Pune. Today I am going to discuss the some chromatography part. Chromatography is a technique which is used in analytical chemistry, but as this is widely used in analytical chemistry as well as in pharmaceutical chemistry. But this chromatography technique were discovered by the scientist Michael Sweat. He used to he used the uh, chloroplast, from the plant extract. We want to identify the components into the chloroplast. Now, he used the different stationary phase calcium. Previously, he used the calcium carbonate. Now, the meaning of chromatography is what? Chroma means color and graphy means the images. So, the color detection, graphy means study. Graphy means study. Chroma means color and graphy means study. So the study of the colors which are present in the material. Now there are different types of chromatography. Absorption type of chromatography, partition type of chromatography, and again these types of chromatography having a different techniques. So there are various techniques in chromatography like thin layer chromatography, then column chromatography, then the HPLC, that is high performance liquid chromatography, gas chromatography. All these techniques having a basic principle is that to detection, identification, and the purification of the components. Components, the chemical components or drugs having a impurities, and these impurities can be isolated or detected or purified by using a chromatographic techniques. In the chromatography, there are two major phases. One is stationary phase and another is the mobile phase. Stationary, the name itself indicates that. Stationary phase is a stable, which is not mobile. So this stationary phase is maybe solid or sometimes in cases it is liquid. So now stationary phase may be silica gel in some cases or calcium carbonate, and in some cases it is a charcoal. This stationary phase, the function of stationary phase is to bind the components on its surface. Means this stationary phase adsorbs the components on the surfaces. Then the role of mobile phase is that it unbound that material. Usually stationary phase are polar one, and due to its polarity, the components bind on the surface. So this is about very basic and principle of chromatography. But we are going to discuss here the HPLC. This is the one technique among the all the techniques of chromatography. So in high performance chromatography, various techniques are used. Among them, the reverse phase chromatography, then normal phase chromatography, then size exclusion chromatography, ion exchange chromatography, hydrophobic interaction chromatography. The high resolving power reverse phase chromatography has made it the dominant mode of HPLC for both analytical and preparative separation of peptides and proteins as well as other biomolecules. Now, among these, we are going to discuss here the river phase chromatography and normal phase chromatography. So, here the term is that the hydrophobic. Hydrophobic means water heating or the solvent heating property. The antonym of hydrophobic is hydrophilic. Hydrophilic is what? The solvent loving or water loving, or we can say that in this case the surface loving or the surface heating properties. So let us discuss what is the exact meaning of reverse phase chromatography. The reverse phase chromatography, the polar solvents are used in the separation of the material. The term reverse phase chromatography was used because the reverse phase is a form of partition chromatography where chemically bonded phase is hydrophobic or nonpolar. And the starting mobile phase is polar one, may be water, must be more polar than stationary phase. So there is a hydrophobic interaction, so it is called as the reverse phase chromatography. But in the normal phase chromatography, the reverse phase, this is the reverse from the normal phase chromatography where the stationary phase is polar. So in the normal phase chromatography, stationary phase is polar, but the mobile phase is non-polar one. So stationary phase is polar or hydrophilic, and the starting mobile phase is more non-polar or hydrophobic. So reverse is true in case of normal phase than the reverse phase. So hence the reverse phase chromatography and the term is reverse phase chromatography. Now this is a layout or we can say the construction of chromatography instrument. So in the chromatographic instrument there is a reservoir, then degasser. Degasser, the function of degasser is what? To remove the air bubbles into the mobile phase. Then this is the pump. The function of pump to pump the mobile phase and push into the column. Then this is the injector. The function of injector is that to accept the analyte from the injection. Nowadays, the automatic systems are there into the instruments and just one can just put the vials in the tray and instrument take care itself to take the sample from the vials and push into the column. So the injector push the analyte into the column. Then in the column, this column is equipped with the stationary phase. So in the wall of the column, there is a stationary phase like a pipe. So it has a small capillary size of the column, bore size is small. And as soon as the analyte solution goes into the column, the analytes bound to the walls of the column having a stationary phase, or you can see the analytes are adsorbed at the column according to their capacity at different intervals. Then after the mobile phase goes into the column and this mobile phase unbound these the bonded analytes into the column and push towards the next end or another side. And after some time the components are coming out from the column. Then these components or analytes which are coming out from the column at different interval or at different time can be detected by the detectors. And after the detection of the analyte, the all the uh, components according to their time and wavelength recorded into the system. Now this is the HPLC system. So this is the PC which is attached to the HPLC. This is the reservoir. From the reservoir, there are the some pipes which are goes into the column. Column is placed at the bottom chamber. Here, the sample chamber. This is the panel from which we can give the specification of analysis. And nowadays there are different companies which manufacture, because HPLC is a heart of the industries. These are the list of different detectors which are used in the HPLC, but most widely used detectors are UV detector and PID detectors. Now let us see the applications of HPLC. HPLC means the high performance or high pressure liquid chromatography. So used in different uh, areas, used in molecular weight determination, used in analytical chemistry, pharmaceutical industries, or in the study of drugs, in clinical trials, in food technology, combinatorial chemistry, polymer chemistry, environmental chemistry, and so on. So this is the benchmark technique which is used in pharmaceutical chemistry. I'm going to stop here. Thank you for listening. Thank you.